In section 2.5, we will learn how to write linear equations in the slope-intercept form when we are given the slope and a point or 2 points. We will also learn how to write the standard form of an equation when given a slope and a point or 2 points, and then write an equation of a line that is parallel or perpendicular to the graph of a given equation. In lesson 2.2, we learned that if a function can be written in the form of y equals mx plus b, then it is a linear function. But what do the numbers m and b actually represent? If we look at this graph, we notice that the line passes through points A, 0b, and point C, xy. We notice that b is the y-intercept of line AC. Suppose we need to find the slope of line AC. If we plug in these coordinates to our equation for slope, we end up determining that slope equals y minus b over x. Now let's solve this equation for y. We'll multiply both sides by x, then add b to both sides. We can rewrite this equation as y equals mx plus b, which you should recognize is now in slope-intercept form. So if we know that we found our y-intercept when x equals 0, we can say that the equation y equals mx plus b is the equation of a line where m is the slope and b is our y-intercept. So let's look at the example if we want to write the slope-intercept form of a line with the slope of 3 over 4 and that passes through point 8, 2. We can say that m, our slope, equals 3 over 4, our x value is 8, and our y value is 2. If we plug those values into our slope-intercept equation, we will get 2 equals 3/4 times 8 plus b. Then, to find our y-intercept, all we do is solve for b. We now can rewrite the equation, including our value for b. So the equation of a line with slope 3 over 4 that passes through point 8, 2 is y equals 3/4 x minus 4. So now we have the equation y equals 3/4 x minus 4. It is easy for us to convert this line in slope-intercept form to our standard form if we follow the 3 rules. First, we want to get x and y on the same side of the equation. We can do this by subtracting the x with its coefficient from both sides of the equation. Our second rule is we want a positive value for x and its coefficient. And our third rule is that we want no fractions. So if we multiply both sides of the equation by -4, our equation is now in standard form, 3x plus 4y equals 16, and it follows all 3 rules. X and y are on the same side, x is positive, and we eliminated our fractions. If we remember that the standard form of an equation is represented by ax plus by equals c, we can then rewrite this standard form equation into our y-intercept form. So we know we want to get the y all by itself on one side of the equation. So the first thing we can do is subtract ax from both sides of the equation. Then we can divide both sides of the equation by the coefficient b to get y by itself. That gives us y equals negative a over bx plus c over b. This means that negative a over b equals our slope, and c over b is our y-intercept. When we get negative a over b equals our slope, this also means that the slope is the opposite of a over b. So if the slope equals 1/2, then what is the opposite of 1/2? It would be negative 1 over 2. So our a would equal 1, and our b would equal negative 2. For an example, let's write the equation in standard form of a line that passes through the points -2, 5, and 3, 1. So first, let's plug in the values to find our slope. We get our slope is equal to -4 over 5, which then we can say is equal to negative a over b, or the opposite of a over b. So the opposite of 4 over 5 is 4 over 5. So our A equals 4 and our B equals 5. Then we can substitute these values into our standard form and then substitute the coordinates for one of our points to find our C value. So our final equation in standard form would be 4x plus 5y equals 17. Since parallel lines have the same slope, if we're asked to find the equation of a line that passes through the point 4, 6 and is parallel to y equals 2/3 x plus 5, we know the slope of a line parallel to that equation is also going to have the same slope of 2 over 3. Our x equals 4 and our y equals 6 from the point we have given. 6 equals 2/3 times our value of x, which is 4, plus b. We then get b equal to 10/3, which we can plug in to our slope-intercept equation. Then, if we're asked to put this in standard form, we can just rearrange the equation, which gives us the standard form equation of 2x minus 3y equals 10. Knowing the slope and a point, we can also go straight to standard form. Remember that our slope m equals the opposite of a over b, so our a in this example, a equals 2 and b equals 3. Then if we plug in the values of our point, we can solve for c. We find our c to equal -10, then we can rewrite this in standard form, plugging in our a, b, and c. So we have 2x minus 3y equals our c value, which is -10. So for our last example, we're going to find the value of k if 5x plus ky equals 8, and this line passes through the point 3, 1. This equation looks like our standard form, so we can just plug in the point for the values of x and y and solve for k. So we end up determining that our k equals 7. This last slide is a brief overview in case you were confused about determining the a and b values for a given slope. So we need to remember that m is the opposite of a over b. So if a equals 3 and b equals 4, m would be -3 over 4. If we are given a slope of -3 over 4, then we can determine that our a and b are both going to be positive, so +3 and +4. If our a equals +2 and our b equals -5, then m, being the opposite of a over b, would be the opposite of -2 over 5, or just 2 over 5. If we're given a slope of 3 over 5, then our a equals +3 and our b equals -5, or the opposite of a over b.